In this video, we're going to look at finding the square roots of non-perfect squares. So many fractions and decimals are not perfect squares. That means that we can't write them as a product of two equal fractions. But there are ways for us to approximate the square roots of non-perfect squares. You either use benchmarks with a guess and check, or you can use your calculator. Of course, for this unit, we will be not using the calculator during any assignments or tests or quizzes, but we can definitely use them to check our answer at the end to see how close we are when we approximate. So for this first example, we're going to find the root of 7. The first thing you want to do is think where root 7 would fall in between two perfect squares. So root 7 falls in between the root of 4, which is the perfect square, and the root of 9. So the root of 4 is 2, and the root of 9 is 3. And I know that root 7 falls in between this. So now what we can do is we can write some increments in between root 4 and root 9. So I know I have a root 5 in here, a root 6, a root 7, and a root 8. And the one I want is here, this root 7. So we know the first number, our whole number, is going to be 2. Coming from the last unit when we're looking at number lines. So this will be the front number. And then now I'm going to find my mixed number for it. So remember, between my two endpoints, my line has been broken up into 1, 2, 3, 4, 5 pieces, which gives me my denominator. And root 7 is 1, 2, 3 away from root 4. So then we're left with 2 and 3/5. We can also write this as a decimal number. 3 over 5 is the same thing as saying 0.6. And then that would be it for my answer. We can also check our answer, and we should check our answer at the end just to see how close we are. If we're really far off, then we know we made a mistake. But if we're really close to this, if it's 2.6, 2.7, or 2.5, those are acceptable answers. So if you want to check in your calculator, this is what you're going to look for. Some calculators will make you do the root sign first, and then you write or tap in the number, and then you'll tap in the equal sign. And then it'll give you the answer. Or depending on your calculator, it might make you tap in the number that's inside the root sign first, which is 7 in this case, and then the root sign, and then the equal sign. Usually the root sign could have a little number 2 in the corner, and that's the one you would want. You don't want the cube root one, which is this. You don't want that one, and you don't want one that says A or a B with a root either. So make sure if your calculator distinguishes between them, that you're picking the one that has a 2 in it. Or maybe won't even have anything at all. Okay, so when I plug this into the calculator, I actually got 2.646. So we are really close to the exact value of root 7, just by approximating. That's good. So this next example here is a fraction. The first thing I want to do is convert it back into a decimal. And we can rewrite this as a mixed number first. This is 1 3/5, which is the same thing as saying the root of 1.6. The same method applies. We're going to see where the root of 1.6 can sit in between for two perfect squares. So sit in between root 1 and then root 4. The root of 1 is 1 and the root of 4 is 2. So I know that this is going to be 1 point something for sure. And now we're going to break down our increments in between here. Well, I know I have a root 2 somewhere, a root 3. Maybe I should write that farther apart actually. So this is root 3. And 1.6, well, it might help me if I draw even more increments in between here. That will be the root of 1.5, the root of 2.5 and the root of 3.5. And I know what that 1.6 is fairly close to 0.5. Well, if I moved it over just a little bit, then I'll get 1.5, which would be a lot easier for me to find the fraction for. So let's just do that and just say that it's going to be about the answer I'm going to find. So the squiggly equal sign means about, or approximately. So same thing as before, we can see how many times we've broken up our line between one endpoint to the other. So that'll be 1, 2, 3, 4, 5, 6. My denominator is 6 then. And then how far away is 1.5, the one I'm actually going to use? It's 1 away from 1. So that's my numerator. If I want to convert this into decimal format, this is approximately 1.2. And then that's it. That would be your approximation here. Okay, this next one is a different method. You'll do this method for when the number on the inside was smaller than 1. So you're going to use this method for every time your number is smaller than 1. So what we're going to do is, instead of making it into a decimal, we're going to make this into a fraction. It's already a fraction, but we can manipulate this into another fraction. So this is the same thing as if I times top and bottom by a 10. So that'll be 30 over 100. And you're probably wondering, well, why do I want to do that? Well, the thing is, I know what the root of 100 is. The root of 100 is 10. And then I would have the root of 30 on top. Okay, well, the thing is, I don't know what the root of 30 is, but I do know what the root of 36 is. That's kind of close. And the root of 36 would be 6 over 10, which is 0.6. So we could say, well, it's approximately, the root of 3 over 10 is approximately 0.6. Now, if I were to put this into my calculator, what I actually get, if I put this into my calculator, the root of, and you had to do a bracket of 3 over 10, that would be 0.547. So, I mean, we're kind of close to it, but we're not exact. And that's okay because, like I said, we're approximating. Okay, this next one, the root of 0.4. So remember, we're going to use the method up here. We're going to change it, the 0.4, probably into a fraction. So we know that this is the same thing as saying 4 over 10. Well, I know what the root of 4 is, but I don't know what the root of 10 is. And remember that you can always separate your root signs. When we have a big root sign here, we can separate into 2 separate root signs. This is only okay for division and multiplication. Okay, so we know this is 2 over root 10. Well, this is pretty close to root 9, no? Because I know what the root of 9 is. That's 3. And I know that's technically 0.6 repeating, but I'm just going to say maybe a better approximation would be 0.6. Why? We want to round down because the root of 9 is smaller than the root 10. So when you divide, let's say 2, because we have 2 in our numerator, by a smaller number, you're going to get something that's larger than if you were to get, if we were to put it under a smaller number or a larger number. So let's think about it this way. 2.4 is the same thing as a half versus 2 over 3. This is 0.6 repeating versus this is 0.5. So if I look at the difference between these, well, I know that 2 over 4 is going to be smaller than 2 over 3. Okay? But look at my denominators. My 3 is smaller than 4, but when I put under fraction like that, it would produce a larger number. 2 over 3 is larger than 2 over 4. So same sort of scenario, if I put 2 over root 9, I'm going to get a larger number than if I had 2 over root 10. But what I really wanted was 2 over root 10. So that's why I want to round down, because I know that when I made my approximation, I made a larger number than what I'm supposed to. So that's just an explanation of why we want to round down. Okay, so the next one, root of 1.5. So this is going back to the method over here, up here, when we were using a number line and benchmarks. Okay, so 1.5 sits in between the root of 1 and the root of 4. Which the root of 1 is 1 and the root of 4 is 2. And we know that root 2 sits in here and root 3. So root 1, root 2, root 3, root 4. And 1.5 would be in between root 1 and root 2, right here. So this would be equal to, or about equal to 1, because my endpoint here is 1. And then I'm going to create my fraction beside it, which is 1 over, and it's been broken down 1, 2, 3, 4, 5, 6 times. So this is about 1 over 6, which is about 1 over 2. And if you notice, when we calculated this before, we had something similar, and we also got 1.2 after we took the root. But that was 1.6 and this is 1.5. Like I said, these are not exact, right? We're just approximating. And if I actually were to put in this into the calculator, I would get 1.2. So once I plug this into the calculator, I got 1.225. So this one's pretty close. Versus this one, because I rounded quite a bit, I got 1.265 on the calculator when I did this one. So once I put in the calculator for this, for B of 8 over 5, I actually got 1.265. I mean, like I said, we're pretty close. We're just off by the hundredths. But in the end, that's what approximating is about. It's hard to do this exactly without a calculator and just on the top of our heads like this. Okay, this last one here. Again, same method as above. We're going to write this in terms of a decimal number. So this would be the root of 3.17. After you convert to mixed number and try to manipulate it a bit, you could have gotten a different number like 3.2 or 3.1. That's okay. Like I said, we're approximating. So root 3.17 would sit in between the root of 1 and the root of 4. So the root of 1 is 1, the root of 4 is 2. And I have root 2 in here and root 3. Well, if I want to draw this on the number line, the root of 3.17 is going to be really close to to root 3 here. We can maybe even say, well, why don't we just calculate root 3? Because that's a lot easier for us. So if we do that, this will be approximately 1 and some sort of fraction. That'll be 1, 2, 3 would be my denominator because it's been broken up 3 times. And then root 3 is 1, 2 away from 1. Okay, now we're going to do a little bit more approximation again, because remember, we changed our question. We're supposed to find the root of around 3.1 or 3.2, and in the end I did the root of 3. So I went smaller than what I'm supposed to, so why don't I round up? But first of all, 1 and 2 over 3 is about 1.6 repeating. And I know that the root of 3.17 should be larger than root 3. And because I know that and I calculated root 3, why don't I just round up then? So we can say this is actually approximately 1.7 instead. And now let's put this into our calculator and check. So let's do 19 divided by 6, and then we'll take the square root of that. And once I put it into my calculator, the root of 19 over 6 is about 1.78. So we're, like I said, it's okay to be off by 100th like that, or even if you had just 1.7 or 1.8, it's fine because we're approximating. As long as I can see the logic is correct, you're going to get full marks even if you are 0.1 off. That's fine. So you need to practice these type of questions a lot, because I know that these questions are rather difficult to do, and there's a lot to kind of memorize and conceptualize. So you have to look through these problems. I would suggest you actually do these again without looking at the solutions before you go on into the practice problems. And if you have any questions, just let me know when I see you next time. And that's it.